A 75 milliliter solution of HCl with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of a 0.157 molarity CaOH2. What was the concentration of HCl in the original solution? As you can see, I underlined the volumes in red, 75 milliliters and 27.3 milliliters. The concentration of HCl is unknown, and the concentration of CaOH is 0.157. As you can see right here, I wrote that out again, just to reference it back in an easier way. So, what are we solving for? We're solving for the concentration of HCl. And another important thing to note is that this is a titration problem. After we write out what we are given and what we are solving for, our step one is to write the balanced equation. Our balanced equation is going to be comprised of our reactants, CaOH2 and HCl, and our products, H2O plus CaCl2. It's important to write down this. Ca2 plus, OH minus 1, and H plus 1, and Cl minus 1. This will help us determine what our balanced equation will look like. So here is the balanced equation. Let's talk about it. Over here, we have 1 Ca along with this side. Over here, we have 2 Cls along with this side. Over here, we have 2 H's plus 2 H's, giving us a total of 4. 4 H's are on the product side as well. 2 oxygens on the reactants and 2 oxygens on the products. A common mistake made by many students is to forget to write a balanced equation, so make sure this is your step one. So next is step 2. Step 2, we're going to draw a picture. In this box, we're going to have our HCl's, and in this box, we're going to have our CaOH2. So, let's do it. We have H over here, and for every one H, there's 1 Cl. So, over here, we have 1 Ca, but 2 OH minuses. That is because for every 1 Ca, there are 2 OHs. So let's draw our charges. H, right here, plus 1. Cl, minus 1. Ca has a plus 2 charge, and OH has a minus 1. This is important to write down. A common mistake made by many students is they forget that there are 2 OHs, or 2 hydroxides, for every 1 Ca. So, the volume given in HCl is 75 milliliters, which was given in the problem. But since we are solving for the concentration, there's a question mark by it because we do not know it. The volume for CaOH2 is 27.3 milliliters, and our concentration was given in the problem, and it's 0.157 molarities. Just one more thing I would like to point out about this step is to make sure that the ratio for Ca and OH is a 2-to-1 ratio. Next, we're going to move on to step 3, which is to find the moles of CaOH2. This is the molarity equation. Concentration equals moles over volume. We're going to rearrange this equation to be moles equals volumes times concentration. This is a capital M, and this is moles. This is an important thing to note, to not confuse molarity and moles. The volume is given to you of CaOH2 in the original problem, and so is the molarity. So we will use that to find the moles. So the final part of step 3 is going to be this. Convert milliliters to liters, which is a common mistake made by many students. So that is an important thing to note. So finally, we're going to do our calculations. The moles of CaOH2 is going to be molarity, 0.157, times liters, 0.0273 liters, giving us the moles of CaOH2, which is 0.00429. Next, we'll move on to step 4. Before we can find the concentration of HCl, we're going to find the moles of HCl. So, we just found the moles of CaOH2. So we're going to bring that down and use the mole-to-mole ratio conversion to find the moles of HCl. So let's plug in the numbers and find the amount of moles. So the next part that I did of step 4 was I plugged in the numbers of the equation to find the moles of HCl. So here's what we did. We found 0.00429 moles of CaOH2. Then we did our mole-to-mole ratio, 2 moles of HCl over 1 mole of CaOH2. An important thing to note, and a common mistake made by many students, is that they forget to look to the balanced chemical equation. Do that in order to ensure that your mole-to-mole ratio is correct, giving us a 0.00858 moles of HCl. Moving on to step 5. Step 5, we're going to find our concentration of HCl, which is what the problem is asking for. We are going to use the molarity equation, the concentration equation, in order to find the concentration of HCl. We're going to use the moles of HCl over the volume of HCl. The moles of HCl was just found right here. And we're going to divide that by the given volume. So let's solve it. So plugging in the numbers, the moles of HCl over the volume given. The volume given in the problem is in milliliters, so we are going to convert to liters. So make sure you do that. When you divide the moles of HCl over the volume of HCl, you get the concentration of HCl, which is 0.1144 molarity of HCl. And you are done with your problem.